Hey everybody, today we're going to have a look at simple radar elevation calculation. During a mission, we're going to get three pieces of information from AWACS about a target we need to intercept: the bearing, the range, and the altitude. We don't need to worry about the bearing for what we're doing today, but we are going to use the range and the altitude to figure out exactly where we need to point our radar in order to build a solid track. And coming from someone who failed math class, I promise we're going to make this as easy as possible. So the distance to the target is the green line here, the hypotenuse of the triangle. And that's known in radar terminology as the slant range. The purple line is the vertical displacement. And that is the difference. When we get to the examples, this will make more sense, but that's the difference between your altitude and their altitude. And the blue angle, obviously that's the radar elevation. So we can have a quick look at the formula we're going to use today. And radar elevation equals vertical displacement divided by the slant range times 100. So let's put that into practice. So here we have a scenario where the aircraft we're trying to get on radar is 100 nautical miles away from us, and it's 5,000 feet above us. So thinking back to elementary school, we have to follow the order of operations. So the first thing we're going to do is the multiplication. So we'll take the distance in nautical miles, which in this case is 100, and multiply that by 100. And from that we get 10,000. After that, all we have to do is plug in the vertical displacement. So now we have a formula: 5,000 divided by 10,000. And the solution we get from that is a positive elevation of 0.5 degrees. I told you it would be easy. Let's move on to another example. So now we're gonna make things a little more difficult and do this with the amount of information you'd have in the real world. So hopefully by this point you're able to figure out what your altitude is at a given time. So let's say our aircraft is at 20,000 feet. We've been given by AWACS a bra, so the range is 60 nautical miles and the altitude of the bogey is 23,000 feet. So what we're going to do next is plug that into our formula. So the radar elevation equals vertical displacement divided by slant range times 100. First thing we have to do is the multiplication. So 60 times 100, we're going to get 6,000. Then we divide 4,000 and 6,000. And from that we get a radar elevation of 0.66 degrees. One thing you have to bear in mind: if the target you're looking for is below you, your vertical displacement will be negative. And if you run the same formula, you'll get a negative number for your radar elevation. So this formula is the example we just did. The only difference is we're at Angels 24 and they're at Angels 20. So now it's your turn, and I'm going to give you until the end of the song to figure this out. If you need more time, just pause the video. So the first thing we do is plug in all the information we have. We know they're 9,000 feet below us and they're 53 miles away. Order of operations, we do the multiplication first and get 5,300. Next, we do the division. And here's your answer. Once you've done this a few times for real, you'll start to notice a trend, and with a little practice you can put the calculator away and just estimate. We don't need a perfect radar elevation solution, but the closer you are, the faster you'll be able to build a good track.